Hey everybody, today we will do another quick video and it's going to be very quick. It's going to be a lot of fun too, a very fun video. So just nice. It's going to be nice. It's going to be very meaningful video. Interesting. But yeah. So it is a related rate. Related rate. If I can take this out. Related rate problem. Okay, so and the reason why I'm doing this is because we're not done with the counting in the election yet, and I want to make it sure that I do this before the counting of the ballot is done. It's complete, right? Because technically we're not, Interestingly enough, our or yours, I will say, your president of the United States, because I don't think it's mine, but that's said that somehow he thought that the only thing that he thought that it was garbage for him was the Trump supporters, right? That's what he said. Okay, so now, interesting enough that he called us garbage, trash, right? Or garbage, you can say it. So we will do something similar, right? So let's say that you have a garbage can, right? Garbage can, right? So we have something like this. So you have it something like that, right? They come in different forms, but I'm not gonna try to okay, so I'm not gonna try to do a square one or elliptical shape one, whatever, right? But you have some height right here, and so have some radius, right? You have some height right here. Okay, so now you're putting right here, you put in trash here, right? And because he called us trash, right? You dump an ass inside the garbage can, right? Isn't it? Isn't it beautiful? Okay. So the problem, let's say for example, it says that a cylindrical cylindrical garbage, and I want to say garbage because that's what he said, right? Can, right? Is being filled. A cylindrical garbage can is being filled. So it's being filled up, right? It's being filled at the rate of at the rate of 2 feet 2 feet 2 feet per minute, right? Per minute. So it's going to be a lot of trash, right? But I just made this problem up, so it's not, this is not 2 feet. Technically it's skewed. This is the volume, right? Now, interestingly enough, right? So that is the rate that is being filled, right? Then okay, so now assume, okay, we'll do assume that the garbage is being compacted. When put inside of the garbage can. Right? Why? Because trash is normally not dense volume. So in order to put meat inside the trash can, you have to step on me, right? Because I am garbage, right? I am garbage. Okay, so you have to kind of compact me down in order to fill up the trash, in a uniform volume, right? Okay, so now we need some more information, right? The trash can, the garbage can, the garbage can, the garbage can is has a radius of has a radius of has a radius of 8 inches. Of 8 inches, right? Okay, so now it has a radius of 8 inches. So that's all we need, right? We don't, because we have a related rate problem. We know the rate, we know the radius, right? Now, so trash is being, garbage is being put in this trash can, and then we need to find the rate, and then we have to find another rate. Now the problem says find the rate. Okay. Okay. I can say it like this. At, right? So at what rate? At what rate is the height? Is the height, right? Is the height of the garbage, of the garbage can increasing, right? That's all we need. Okay, so that's a question mark. That's what we need to find. Then the rest is very simple problem, right? So the formula for the volume is the following. The formula for the volume for a cylinder is V is equal to pi r squared, right? Times the height. Now, believe me, right here we have a rate of change. So this is calculus, but it's basic calculus. We need to do something, right? So we have we have is the rate of being filled, right? So we looking for the rate of the height. What is that how fast that height is increasing, right? Okay. So now notice that we have something right here, right? So we have it right here. So let me just write it right here. So V equal to pi r squared times h. Notice that we have the rate, so we need to take the derivative, right? So we say dV dt, the volume, right, with respect to time is changing, and now this is going to be equal to the other side, which is going to be equal to pi r, right? Pi, but r is a constant, right? Because r is this space, this right here is nothing but 8 inches, right? So this is 8 inches. That is 8 inches, right? So now what is, and notice that, so my first step is to take the derivative, but the derivative of what I want to find. What do I want to find? What do I want to find is the height, right? The increase in height. So which means that I need to take the derivative with respect to h. So in this case, I will say r is a constant because it's not changing, right? If you slice this, the radius is the same all the way up. So it's increasing, right? Notice that I have what is called implicit differentiation, which is called, if I take the derivative over here, I need to take the derivative on this side implicitly. So dh over dt. Now, notice that I already have the rate to that, right? That's the rate. So now what I need to do is the following, which I need my little calculator, because I have to deal with pi. So right here, I replace 2 is equal to what? Is equal to pi r squared, right? Pi r squared, right? Now, but what is pi r? What is r? R is 8 inches, right? R is 8 inches, right? R is 8 inches, right? So now what you can do right here is also convert that into, if 2 foot is 24 inches, right? I mean 2 foot is 12 inches, right? You can actually say that this is, and instead because you have an inches over here, you can put the 24 right here. Inches cubed, right? So that way you have inches on both sides. Okay. Now what you do is, because, you know, to make it easy, right? So now what you do right here is the following. So I have this and I square it, right? And I say dH over dt is equal to that, right? It's now all I gotta do at this point is the following. So take 8 squared is 64, right? So 64 times, you know, to be accurate, 3.1415, but you know, to be accurate, 3.1411, more accurate, I will say, 15. So that is equal to 24 is equal to 201 dH over dt. Divide this by 201, both sides divided by the 201. So now, if you take that, right, so you get 24, and then divided by, it's equal to point 0.19 is equal to dH over dt. That is basically the rate of change. And notice that also this is the height. So if the height was in feet, this is also in feet. This is also in feet cubed, right? So interestingly enough, is 0.119, right? Inches or whatever, because it's inches cubed. Okay, so that is the increase in height. So that's very neat type of problem, right? So basically you got a bunch of Trump supporters, right? And you pack them down and you fill the trash, the garbage can with them. That is the rate of change right there. That is the height. In this case, it's not, it's the rate of change is not a lot, but that's how it's done. So thank you for watching, and see you in the next video. Yes,